Now let's focus on a little bit of vocabulary. Let's look at these prefixes mono, bi, tri, and poly. A monomial is an expression that has one term. A binomial is an expression that has two terms. A trinomial is an expression that has three terms. Now, normally poly refers to many as a prefix, and so we would say many terms. However, I'd like to make a correction here in mathematics. Here we say it can be any of the above also. Any of the above. Now, let me give you an example. If you were in Texas, someone would say, "Hi, y'all, how you doing?" That is both singular and plural. How are y'all doing could be said to the entire class, or you could talk to one person and say, "How y'all doing?" That refers to both one or many. Same thing with the word poly. Polynomials can refer to one term, two term, three terms, or a many-termed expression. Now, as far as vocabulary is concerned, the number that is out in front of the highest exponent is called the leading coefficient. And you've probably heard me in some of the other videos using that vocabulary. And the last number that does not have a variable is called the constant term. Sometimes I refer to that as the trailing constant. When you write polynomials, we always write them with a descending order of exponents. So, given this expression or polynomial, identify the leading coefficient. Well, that is the first coefficient, which is 5. The constant term will be this -11. Now, the degree of the second term says look at the exponent in that second term. That is an exponent of 6, and so that will be 6. Now, that is only when you have a single variable x. If there's multiple variables, as we'll talk about in a little bit, that might be a little bit different. For the degree of the polynomial, you look at the degree of each of these terms, and if it's in descending order, the largest degree will be listed first, and the degree of that term will be the degree of the polynomial. So for this polynomial, the degree is 7. So you have degrees of terms and you have degrees of the entire polynomial. Now, if there's more than one variable, the degree is the sum of its exponents. So as you can see here, I've got the expression 5x squared y to the 7th. You will add 2 plus 7 to say that this term has a degree of 9. In order to add polynomials, you will basically just add like terms, those having the same variable part. 3 plus 7 is 10, and so we will have 10x squared. Keep it as an x squared. Do not make that x to the 4th. For the x terms, we have 5 and -9, which add together to become -4, so we have -4x, and then -2 plus 13 is +11. Now that cannot be simplified. That expression is going to be the combined polynomial. Now, the only reason we had parentheses here in this problem was to separate the first polynomial and the second polynomial that were being added together. You can also add polynomials in a vertical format if the like terms are aligned. So 5 plus 8 is 13. We will have 13x to the 3rd minus 6x squared. Just pretend there's a 0 where that hole is, and we will then have plus 5x plus 8. You know that to find the perimeter of a polygon, you add up the lengths of the sides. Well, we will do the same thing here. I'm going to put a little marker there so I know where I've started. 5x plus 8x is 13x, plus 6x is 19x, plus 6 more x is 25x, plus 8x makes 33x, and that marker says I've gone all the way around the shape. Now let's focus on the constant terms. 3 plus 2 is 5, minus 4 is 1, minus another 4 is -3, plus 2 is minus 1. So the perimeter will be 33x minus 1. It is a common mistake with subtraction to not distribute the negative. I think it a good idea that you rewrite this with a middle step here. You do not need the parentheses on the first polynomial anymore. So I'm just going to drop them off, and then make this minus x squared minus 7x plus 4, multiplying this negative 1 into that second parentheses. Now I will combine each of the like terms one at a time. 3x squared minus 1x squared is 2x squared. 5x minus 7x makes minus 2x, and 11 plus 4 makes 15. If you are subtracting in a vertical format, then you've got to be careful because each term on that second row is being subtracted and we're adding the opposite, so you will want to change the sign of each term in that second row. Just putting one minus sign out front is not enough. Now we can add the opposites. 5 plus negative 2 is 3x to the third. Then we have minus 9x squared plus 15x and minus 17.